In 1958, a wave taller than the Empire State Building was born on Earth. This is not a metaphor. It was a real wall of water that reached an estimated height of over 1,700 feet, or 524 meters. In a matter of moments, it scoured entire mountainsides clean, stripping away ancient forests and soil, leaving nothing but bare rock. This cataclysm didn't happen in the open ocean, and it wasn't caused by a meteor or an underwater volcano. It was a chain reaction of natural forces that many thought was only theoretical. A perfect storm of rock, water, and gravity in a remote Alaskan bay. How can such simple ingredients combine to create a wave of this impossible scale? And more importantly, what does its existence tell us about the hidden dangers lurking in our world today? To understand this event, you must first understand the place. Lituya Bay, on the southeast coast of Alaska, is a place of profound, almost severe beauty. It's a fjord, a long, narrow inlet of the sea carved by glaciers, shaped like the letter T. The water is often mirror calm, reflecting steep, forested mountains that rise directly from the shoreline. At the head of the bay, massive glaciers, the Lituya and North Krillin, calve ice into the water with a distant, thunderous crack. For centuries, it has been a seasonal fishing ground for the Tlingit people, and a remote, quiet anchorage for the few mariners brave enough to navigate its tricky entrance. It is a portrait of geological time, a place that feels ancient and undisturbed. But this serene landscape holds a violent record. On one of its slopes, there is a sharp line where a dense, old-growth forest abruptly stops, and younger, smaller trees begin. This is the trim line, a scar left by the 1958 wave. The highest point of this scar is 1,720 feet, 524 meters, above sea level. Let's be very clear about what that number means. It is not the height of the wave itself as it moved through the bay. That would be physically impossible. It is the run-up height, the maximum elevation that the water, propelled by an incredible force, surged up the mountainside. It was a splash of biblical proportions, an aqueous explosion that had enough energy to climb higher than the tallest skyscrapers of its time. This is the central puzzle of Lituya Bay. The evidence is carved into the rock itself, confirmed by geologists. Yet it defies our standard model of a tsunami. A typical tsunami is generated by a massive earthquake under the ocean floor, creating a series of waves that can travel across entire oceans. This was not that. The wave at Lituya Bay was a local phenomenon, contained almost entirely within this 7-mile-long inlet. It was born there, and it died there, all within minutes. So, if it wasn't a conventional tsunami, what was it? The scale of this event is almost too large to comprehend. But on the night of July 9th, 1958, there were people inside Lituya Bay, and they saw it happen. Their terrifying story is the key to understanding how it was even possible. On the evening of July 9th, 1958, the waters of Lituya Bay were still. 3 small fishing boats were anchored for the night. The Badger, with Howard Ulrich and his 7-year-old son. The Edry, carrying Bill and Vivian Wagner, and the Sunmore, with Orville and Mickey Swanson. The sky was clear, the air was calm. It was just after 10:15 p.m. Then the world broke. A violent tremor seized the bay. It was the Fairweather Fault, a massive geological fracture that runs right under the landscape, unleashing a magnitude 7.8 earthquake. For the people on the boats, it felt like the entire planet was being torn apart. Howard Ulrich was jolted awake as his boat was tossed violently. He grabbed his son, struggling to stay upright as the mountains around them shook. But the shaking was just the prelude. From the head of the bay, 9 miles away, came a sound he would later describe as deafening, like the explosion of an atomic bomb. Looking up the inlet, he saw something incomprehensible. In the twilight, the face of a mountain seemed to blur, contort, and then simply vanish into the water. In its place, a white wall rose from the depths. This was not a wave like one sees in the ocean. It was a solid vertical front of water, filling the entire width of the narrow bay. It moved with the speed of a jet plane, a churning, grinding monster of water and debris. On the Badger, Howard Ulrich somehow managed to pull his anchor and point his bow toward the advancing wall. He rode the wave, a tiny cork on a liquid mountain, as it lifted his boat hundreds of feet into the air. The Wagners on the Edry were not so lucky. Anchored near the mouth of the bay, they were caught by the wave's crest. It lifted them up, over the spit of land that separates the bay from the ocean. For a terrifying moment, Bill Wagner looked down and saw the tops of 80-foot spruce trees passing beneath his boat before they were dropped into the open sea. The third boat, the Sunmore, was caught directly in the wave's path and disappeared without a trace. The survivors' accounts were so extreme they bordered on fantasy. A wave that lifts a boat over an island? It sounded impossible. But when geologists arrived to investigate, they found the proof of this impossible story etched into the very rock of the mountains. And that proof revealed the true nature of the monster. The story told by the survivors was so extreme, it forced scientists to ask a fundamental question. What kind of force could do this? The answer is not a traditional tsunami. What happened in Lituya Bay was a different and, in some ways, more violent phenomenon. A landslide-generated displacement wave. The physics are brutally simple. Imagine dropping a huge rock into a full bathtub. The water doesn't just gently rise, it explodes upwards and outwards in a violent splash before a wave radiates across the surface. Now, scale that up to a geological level. The magnitude 7.8 earthquake didn't just shake the ground, it acted as a trigger. It dislodged an entire mountainside at the head of the bay, in a narrow arm called Gilbert Inlet. Researchers calculate that an unbelievable mass of material, about 90 million tons of rock, ice, and soil, fell as a single solid block. It plunged from a height of up to 3,000 feet, accelerating under gravity, and hit the water at immense speed. The impact was instantaneous and catastrophic. The energy released was like a bomb going off. But instead of an explosion of fire and gas, it was an explosion of water. The unique T-shape of the bay was critical. The landslide hit the water in the narrow, dead-end top of the T. The water had nowhere to go but up. This initial violent splash is what scoured the opposite mountainside to its record-breaking height of 1,720 feet. This was the run-up. A jet of water and debris fired like a cannonball. It was not the wave that traveled down the bay. That wave, the one that Howard Ulrich and the Wagners faced, was the ripple that spread out from the impact. It was still a colossal wall of water, likely hundreds of feet high, but it was the secondary effect of that first incredible splash. The narrow fjord then acted like the barrel of a gun, channeling all of that energy in one direction, straight towards the mouth of the bay and the unsuspecting fishing boats. The physics provide a terrifyingly logical explanation. But how can we be sure this wasn't a one-in-a-billion-year fluke? The answer was waiting in the trees. Or rather, in the complete absence of them. And it connected this modern disaster to a much deeper, older story. The physics of the landslide explained how the wave was created, but the most chilling proof of its power was left on the landscape itself. When geologists surveyed the bay after the disaster, they saw a feature that was both stunning and terrifying: the trim line. It's a sharp, distinct boundary etched across the mountainsides. Below this line, everything was gone. An entire ecosystem. A dense, centuries-old spruce forest, the soil it grew in, all life had been scoured away, leaving nothing but naked, pale rock. Above the line, the dark, ancient forest stood completely untouched, as if nothing had happened. This was the wave's high water mark, a gigantic scar that perfectly matched the survivors' seemingly impossible stories. The trim line confirmed the run-up, the incredible splash that climbed 1,720 feet up the mountainside. The evidence was irrefutable, carved into the planet. The 1958 event was not an exaggeration. It was a confirmed catastrophe. But as researchers studied the bay, they realized this scar was not the first. By examining the growth rings of the trees along the trimline, they found evidence of previous similar events. This modern scientific discovery echoed something that the Tlingit people, the original inhabitants of this land, had known for centuries. Their oral traditions, passed down through countless generations, speak of the bay's violent nature. Their stories warn of a powerful spirit or monster living within Lituya Bay, one that would periodically rise up and cleanse the inlet with a colossal wave, destroying anyone caught inside. For a long time, these were considered myths, but now they are understood for what they truly are: a precise, multi-generational human record of recurring megatsunamis. This is a profound convergence. Modern science, with its satellites and seismographs, and ancient indigenous knowledge, preserved in story and tradition, arrived at the exact same conclusion. The 1958 disaster was not a freak accident. It was simply the latest and most well-documented chapter in Lituya Bay's long and violent history. The evidence was undeniable. Lituya Bay is a natural laboratory for creating giant waves. Science and history agree. This forces a critical question. The ingredients that created this perfect storm, the fault, the steep mountains, the deep water, are they unique to this one remote bay? Or is this recipe for disaster waiting in other places around the world? The brutal lesson of Lituya Bay is that its disaster was not born from a supernatural force or a violation of physics. It was the product of a specific, repeatable, and terrifyingly logical recipe. The ingredients are simple. First, you need an active tectonic setting, a place where the Earth's crust is under immense stress, capable of producing powerful earthquakes like the one on the Fairweather Fault. Second, you need geology shaped by ice, extremely steep, unstable mountain slopes plunging directly into a deep body of water. Finally, you need that water to be in a confined, narrow basin like a fjord, which acts to contain, focus, and amplify the wave's energy instead of letting it dissipate. This forces the most important question of all. Where else on Earth do we find this dangerous combination? The answer is unsettling. The same conditions exist in fjord systems all over the world, in regions of stunning beauty and hidden volatility. The coasts of British Columbia, the fjords of Chile and New Zealand, the dramatic shorelines of Norway. All of these places share components of the Lituya Bay recipe. And today, there is a new and powerful accelerant being added to this ancient formula: a rapidly warming climate. For millennia, massive glaciers have acted as a buttress, a heavy brace of ice pressing against the mountainsides they carved, holding them in place. As these glaciers melt and retreat at an accelerating rate, that support system is being removed. The mountains are, in a very real sense, being allowed to relax and slump. This dramatically increases the risk of catastrophic landslides into the newly exposed fjords below. This is not a theoretical danger. In 2017, in Carrot Fjord, Greenland, a massive landslide collapsed into the water, generating a tsunami that devastated a nearby settlement. The event was a smaller, modern echo of Lituya Bay, a deadly reminder that this hazard is real and present. The 1958 Megatsunami was not an impossible wave. It was a terrifyingly clear demonstration of geological power. It taught us that some of the world's most beautiful landscapes are also the most fragile. By decoding the chain reaction that happened in that remote Alaskan bay, we gain the crucial knowledge needed to identify, monitor, and perhaps one day mitigate the risk in other vulnerable locations, before they, too, are struck by a wave that seems to come from another world.